Hello, thanks for tuning into my screencast on my Capstone inquiry math activity. This activity that I chose, I named it Triangle Side Length Exploration, and here's the student handout for it. So this activity relates to the 7th grade math standard for the triangle inequality theorem. And you can see in the directions here that the students will be given some materials and they'll be asked to draw different triangles that have two fixed side lengths, and then they change the third side, and then they have to calculate the perimeter based on those changing sides and then tell me, okay, this side length resulted in the largest perimeter, this was the smallest. In the first part, I give them two side lengths, and then in the second part, they are coming up with two of their own side lengths. So this gives them a little more freedom here, but they're still basically doing the same thing. They're going to pick two side lengths, keep them the whole time, and then just change that third one for what they can. And I do ask them to use just whole number side lengths the whole time. That way we don't deal with any decimals or fractions or crazy things like that. But I could definitely extend this and have the kids have some rational number side lengths. And then in the end, down here you can see after they've completed both challenges, they're going to get together with another group and talk about the different side lengths they were able to create for the third side based off of the other two fixed sides. And hopefully this will eventually lead to the development of the triangle inequality theorem. And if they are not able to come up with it on their own or with another group, we will definitely talk about it at the end of class. For the alignment of this activity to STEM practices, I did think that it was more up here, like figure 8.4 shows. I did think that it taught it as separate disciplines since the math is kind of by itself. I could make it more like in figure 8.5 by allowing the kids to use a computer or a laptop to try to draw some of these triangles. And I could definitely even reach out to the science teacher or tech ed teacher about having them actually construct these triangles and integrating that in with this activity. So there's a lot of room for this to grow. As for how this adheres to the tenets of inquiry, I used this table in the Bible text to answer that question. So I really thought that right up here, this was more in the teacher-directed area because I am providing the students with the materials and the question, but then in the second part of the challenge, they are creating their own question, even though they're doing it based off of the same one they did previously. And I'm also not telling them what materials to use, I'm just giving them a variety of materials. This part in the middle, this is a good balance between the self-directed and teacher-directed, since I am asking them to create all the different triangles and fill in a table, but I'm not telling them how to do it. And then the last part, I think that all of these are mostly student-directed based on the question that they have to answer at the end about what they noticed about the different triangles that they were able to create. And this would even be more in depth with our class discussion that we would have at the end of this activity. So these are all of the materials that the kids would be able to use. I have some tape, a ruler, paper, whiteboard, dry erase marker and eraser, brass fastener, some thread, and scissors. And the reason I included all of these materials is because I would hope that the kids would realize that it's kind of difficult to draw out all of the triangles using a ruler because it's hard to figure out the exact angle you need to get that third side to be a perfect whole number. So I actually took some thread and cut that to lengths of 4 centimeters and 9 centimeters, and then colored it and made it darker so that you could see it. And then I taped that to the whiteboard and used that to make the triangles of different lengths. And I did this a couple times until I was able to fill in the table. And then although I knew it wouldn't work, I did show me again trying to make another triangle that had a third side that was larger, but you cannot make the triangle with sides of 4, 9, and 13. So once I created all the triangles possible, I moved on to the next challenge, and this time I used inches as my unit just to show that this could be done with any unit, and I used 3 and 4 as my fixed side lengths. And then I answered the last question, and I wrote something that I figure my students might write. And again, eventually I would like this lesson to lead to a discussion about the triangle inequality theorem, which you can see here, but in easier to understand language.